Hey, for the latest news, go to SCTE.org for standards, training, certification, events, even membership. Everything you need to know, SCTE.org.
So what makes a PON kind of special? What differentiates it from what we did in the past and what we still do today? What we did in the past was a point-to-point network. Typically, if we're thinking about a service provider network, or this could be a LAN in a building is going to be built this way. Point to point, we start at point A, which is our active component. And in this example, it's an Ethernet switch. But between all of these different units, we have dedicated cabling going from point A out to point B's through Z's, if you will. So this red infrastructure here, in the case of a LAN, this is going to be copper cable. But once you get into the fiber of the home world, you know, this becomes a fiber optic cable. When you're in a LAN, this cable is 300 meters or less. We introduce a new component, and that's called an optical splitter. That optical splitter sits between our point A, the PON. In this case, we've got it labeled as an OLT, but let's just think about this as point A for now, out to our subscriber or our point B. So with a passive optical network, we can take one port off of our point A, bring that into a splitter. My animations are a little backwards, sorry about that. But we can bring one port and one connection into a splitter, and then we get this kind of port multiplier effect out of this splitter. So now we're sharing one port on our point A out to multiple points at the end of this network. And that optical splitter and the optical fiber cable, that's what allows us to get that kind of multiplier effect. This saves a lot of capital expense back here in point A. One fiber in, many fibers out, and you get that port multiplier effect. So you can cover a whole lot more endpoints with less resources at the start of your network. This is what has driven service providers to the PON architectures. It saves a lot of time, a lot of effort in the build outs and, you know, the capitalization and funding of these particular networks.
So that fiber could be a currently deployed fiber that was maybe dark fiber,
yep,
or spares for a traditional HFC node location, and now we can leverage that particular fiber, or even, well, I was going to say wavelengths within the fiber, but at that point you do need a dedicated fiber or multiple wavelengths, right, between your hub location and potentially your OLT, or your OLT and your fiber splitter location. Yeah, and you bring up an interesting point.
What we're doing here is, you know, this is optical technology. DWDM is definitely part of this solution. Hasn't been leveraged a whole lot directly in the PON network itself, but we're doing DWDM concepts here. The idea that we can take this splitter and send that signal out to multiple endpoints, that's part of the DWDM solution set, if you will. And we've been doing, you know, splitting and combining of fibers for different applications for a number of years. PON tends to get it, you know, has standardized it and then kind of put it on steroids. So a service provider can adopt these standards and start building kind of rinse and repeat.